So in exercise 8.12, in the first part, this video is going to be about the first part. We're going to show the provability of this line here in the Gensen system. So the Gensen system in first order logic has the same rules as in propositional logic, only with these 4 additional rules to do with quantifiers. So this is the set of rules which we can use in the proof. And I think I'm just gonna take the opacity down a bit so we can sort of see it, but we can write over that. So we start with this line, and as usual, we want to work our way upwards to the axiom in the Gensen system, which is that gamma and delta are not the empty set. So we'll just start from the bottom here. Okay, so how do we approach this problem? Well, we want to get rid of the for all quantifiers here so that we can split them up, split up these implications and get, for example, an A and a B on each side of the probability symbol. So when using rules to get rid of these for all quantifiers, it is important to note that the right for all quantifier and left existence quantifier, they both require fresh substitution. So while the other two just require a legal substitution, the others need a fresh substitution. So it's always smart to start by using these two rules first, so that you don't have to start introducing fresh variables and just not completing your proof. So we can start maybe by using implication to split these up a bit. So we have an implication here on the right side of the probability. So then we use the right implication rule. So we have right implication, and that means that we get this on the left side and this on the right side. So we have for all x A implies B, for all x A implies for all x B. We can actually just apply that again because we have another implication rule here on the right side. Oops. Yep. So we apply this rule again, and then we get for all x A implies B, and then we move the for all x A onto the left side, and then the for all x B is on the right side. So now we have for all x B alone on the right side, and we can start using this this right for all substitution rule. So we'll apply that rule. See daisy. We'll apply that rule here so that we, instead of B, we have B where x prime is substituted for x in B. And this is also a legal substitution because there are no, x is not a free variable here because it's bound by the quantifier. So then we use the right for all rule, and this side is the same. So we just have for all x, for all x A implies B, for all x A. And here the B changes, of course, so we have B x substituted by x prime, and then we have to remember to write that x prime is fresh, just to underline that this is admissible here. So now that we've done this, we can start getting rid of the quantifiers on the right side by just applying this rule. And here we want to apply it by using x prime as the substitutor, because then we would have the same well-formed formulas on both sides of the probability symbol. So we'll just apply those. So maybe first apply it to the A here, so that we have for all on the left side, and then we apply it to the A. So the first part is the same. We have A implies B, and then if you look at the rule here, we don't actually get rid of the for all A quantifier. We keep it, but we add another one with the substitution. So we keep this for all x A, but then we add x prime here. And then the right side is the same. So we've gotten the A out here. Now we want to get the A implies B out from this quantifier here by applying the same rule. Whoops. So we apply the for all on the right side, and then we, of course, keep this the same as last time. So for all x, A implies B, but then we have A implies B with the x prime substitution, and then for all x A, oops. There we go. Oh yeah, and I forgot to write that. It's important to write that the substitution is legal. So here we write that A with x prime is legal, and here this substitution is legal. And again, it's legal because A implies B is bound by the for all x quantifier. So substituting x is legal. Now we would like to apply the left implication rule, because then we can move the A onto the left side and the B onto the right side. And since we have an A on the left side and a B on the right side, this would solve the proof. I think I'm going to rewrite this though, because we can't apply it yet. Whoops. So I'm just going to rewrite A implies B with the substitution as A substitution B substitution. So what I'm saying is that A implies B with x substituted for x prime is the same as A x prime implies B x prime. So these are the same. I'll just write that. So I'm going to rewrite this part. We have for all x A implies B, and then A x prime implies B x prime. For all x A and A x prime, and we have the B on the right side. Sweet. Now we can apply the left implication rule. So we'll do that. I think I'm going to draw this line out a bit longer because we have to split the proof into two parts. Oops. So we're using the left implication rule, which means that, and we're going to apply it to A implies B here. So that means that we're going to end up with a left branch with A on the right side and a right branch with B on the left side. So we'll write that out. We'll have for all x A implies B, and then we'll just have for all x A and A x prime. And then on the right side, we'll have our B as usual, but then we'll also have our A x prime. So we'll have A x prime. So that's this side of the branch, and then we have this side here, which will be, this will be for all x A implies B, for all x A x prime, And then remember that we have to move this b onto the left side. So now we get the b with x prime. And on the right side, we still have our b x prime. And now we have actually finished the proof because we have reached the axiom where the left and the right side is not the empty set. So we have b on the left side and b on the right side here. So that's good. And then we have a on the right side and a on the right side here. So that's also good. So now we have completed your proof in Gensen to show that this line here is admissible.